Okay, now you remember how we change this power circuit. This one is your mains utility. This is your DG, that is genset, that is standby power. This one is your inverter. So we have three contactors here. I hope you are aware how we come about this for us to minimize space. Okay, all right. Now we want to design control logic for the mains. We are starting from the mains. This is my single pole MCB to protect my control circuit. This supply is coming from here. The input of this contactor is where you are taking this one from. So it is assumed that it's coming this way, like this. Take note. This one is coming from here. Now from there, you enter a switch, cam switch, so that I can on it and off it whenever you don't want the power to come in. You disable from here. That is the essence of this switch. And you know the switch, right? Okay, so let me be showing the pictorial view. So this is the switch. This particular one is this. Okay, let me keep it here. All right, now from the switch to emergency push button. I showed you emergency even from my video. Okay, look at the emergency switch. All right, the number is terminal 1, terminal 2, terminal 1, terminal 2. I told you about auxiliary. NONC, and I told you their terminal numbers. Even if you buy them from market, they maintain that same terminal number. Normally close is 1 and 2. Normally open is 3 and 4. Okay, because this one is emergency close, so it's the same 1 and 2. The same 1 and 2. Now, simple as this. Just come here, take your line, enter the terminal 1, then out from 2, enter 1 here, out from 2, go to the coil of the contactor and terminate it. That is this contactor, the coil, put it there. Then supply the neutral there. You are done. Now let's simulate it. So I put on my MCB. Look at it. The contactor has closed. The lamp is on. I have my load. If I want to shut it down, let me off the breaker. If I on the breaker, it come up. I shut down from here. Now, listen carefully. You know that when utility comes active from the substation, the voltage surge to equipment will be massive. All right, the voltage will be high, the frequency will be high. It will stabilize after few seconds. I repeat, the supply voltage from substation to transformer and from transformer to your local distribution. Once the power is activated from the substation, the voltage will be high. Then when people start loading their equipment, the voltage will now stabilize. So because of that voltage fluctuation and the variance, we don't allow the system to transmit immediately. We want the system to stabilize the voltage before it gives you output. Okay, that is why ATS will first of all absorb the voltage before giving you output. All right. So because of that now, we want to introduce a time delay so that once power comes in, it does not come immediately. It should just digest the instability and the high voltage with few seconds. So we're going to apply a timer. The timer is going to delay for like 2-3 seconds before it now give you output. So let's do that now. Okay, now this is our timer now. Okay, now let's simulate. From here, you feed your timer. Just after your emergency, you tap and feed your timer. Okay, then you use the timer contact and prevent this one not to come in until this one close. So this one will take to timer direct. After timer timing set is completed, here will close. Then I'll get power here. So let's simulate now. I put on mice. It's timing now. It has completed. So I have power here, close. Okay. Okay. Now, remember that I told you that a timer is an electronics component integrated together to form the timing function, and it's a fragile device. So because of that, we are going to interface it now with a relay so that by the time this one will vibrate, okay, or producing contact shutting, it will not flash our timer. So let's put a relay here so that this one will energize a relay while relay take up the load supplying here. So let's do that now. We're going to introduce a relay here, electromechanical relay that is stronger. We're going to be R1. Okay. So how do we feed the relay? The same thing. The power from here will go to the relay direct. If you understand the concept, now this one will no longer supply here. It's going to prevent this. I put it here. Now, this is what is going to happen now. It's as simple as that. So what I'll do now is I'll bring in this one here. Now, upon this one come available, the power is here already. The power come here and start timing. After this one preset time elapse, here will close. Once here close, I will have power here and here will close. So once this one get activated, the contact here will close to supply this. Is it difficult? Let me explain again. Upon closing here, power come here, direct to this one. This one start timing. When the preset time that you inputted on this timer is completed, here will close. When here close, supply come to relay, and this relay contact here will close, and I have power here. Let's simulate once more. Mains active, timer is timing. Look at it, I have my load. Okay. All right, now we are done with this area now. Okay, we are done with here. So what we are going to do next is to design a logic for this generator side of it. Okay, to design logic for this.